Hello and welcome to our video on bubble sort. In this video we will explain what bubble sort is and how it works. Bubble sort is a simple algorithm, that is sorting algorithm, that works by repeatedly swapping its adjacent element, okay, if they are in wrong order. The algorithm gets its name from the way smaller element like bubble to at the top of the list as the algorithm iterates through it. Suppose we have an array list, like we have an array list that is of two, oh sorry, four, that is 4, 2, 7, 1 and 3. We have a given an array. Suppose we have to sort the array using bubble sort. So bubble sort algorithm says that first we compare first two element, okay, first to compare first two element. Suppose here 4 is greater than 2, okay, 4 is greater than 2, then yeah, it is true, 4 is greater than true, sorry, 4 is greater than 2, that is true. So if 4 is, if first element is greater, if first element is greater than its adjacent element, then we have to swap. What we have to swap their positions, okay. So after swapping, what we will, after swapping, after swapping the list is like 2, 4, 7, 1 and 3, okay. And then pointer should move to the second position, okay. We start from the first position and check its adjacent side, adjacent element. Now pointer will move to the second position and we will check its adjacent uh, element like 7, okay. So we compare 4 and 7. 4 is greater than 7? No, no, not at all. It is false, means false. So we do not swap, we do not swap, we do not swap, okay. We make the list as it is. Now our pointer will move forward, pointer will go to the 7th position, sorry, so for in the 3rd position. Now compare 7 with its adjacent, okay, that is 7 is greater than 1, yeah, yes, yes, it's true, 7 is greater than 1. Swap it. What? Swap it, swap it. Then the list will become, then the list will become like this: 2, 4, 1, 7 and 3. Then move the pointer. Previously pointer is at 3rd position, now it is at 4th position, okay. Now check 7 with its adjacent number, that is 3. 7 is greater than 3, yeah, yes, it is greater than 3. Now swap it, swap it, okay. So after swapping, the list become, the list became 2, 4, 7, sorry, that is 3 and 7. Oh, my bad. The 2, 4, 1, 3 and 7, okay. Now see, 7 is a greater in this array, okay, and we found the correct place, correct place for 7, okay. We found the correct place for 7. Now we have to repeat the same process, okay. We have to repeat the same process. for this, for the array, but excluding this position which is in which 7 is placed. Okay, so we have to iterate our list up to 3, means up to at index 0 1 2 3, at index 3. Okay, so let's try it. We start from the starting. Our pointer will be at 2. Its adjacent element is 4. 2 is greater than 4. No, not at all. Continue. Okay, continue. Now pointer will at 4. 4 is greater than its adjacent element, that is 1. Yeah, that is true. Swap. Now list become 2 4. Oh, my bad. After swapping it become 2 1 4 3 and 7. Now the pointer will at position 2. Okay, now check 4 and its adjacent element, that is 3, whether 4 is greater than 3 or not. We have to check. 4 is greater than 3, so swap it. Swap. The list become, now the list become 2 1 3 4 7. Here, okay, here we got correct position for 4. Now once again repeat the same process for till position 0 1 till position 2, because we got the correct position for 4 and 7. Now check it. Our pointer is at 2. Check. 2 is greater than 1 because 1 is its adjacent element, sorry. Yeah, true, it's greater than 1. Then swap it. And list become 1 2 3 4 and 7. It is sorted. Okay, so this is the algorithm. Okay, now let's repeat all the steps again to memorize the algorithm, or to understand the algorithm. We start comparing. Okay, but we start by comparing the first two elements in the list. If the list element is greater than the second element, we swap them. Okay, here we are swapping 4 and here we are swapping 4 and 2. Okay, we then move the next pointer. Here we are moving our next pointer. Okay, that is, it is at 1. Now it will add to 4. Here we will okay 4 position. Okay, now then we in the same way we continue the process until we reach the end of the list. Okay, at this point the largest element in the list have its correct position. Okay, for example, when we iterate through all the element till the end of the list, we got the, and compare it and swapping it, then we got the correct position of the largest element, that is 7. Okay, we then repeat the process for the remaining element until the entire list is shorted. Similarly, we have to short the we have to repeat this process for all the element until we get the sorted array. Okay, so let's move on to code. And one more thing, the time complexity. Time complexity. Time complexity. It is checking for an element. It is checking for the all element. It is checking for the all element. Okay. First of all, it will check for 2, then this, then this, then this, then this. Okay. And it will compare for an element. Okay. So the our time complexity became n square, big of n square. Okay, let's go to the editor so we can write the algorithm. Okay, so hash include, so we have to write its verify using namespace. Seen it. Okay, int array of length n for int I is equal to 0, I smaller than I space scene array of I. Okay, scene array of I. Now we call the bubble short here give the array. Okay, give the array and minus 1 and I is greater than equal to 0, 0, this is smaller than I minus 1 and I plus plus. Okay, here compare